Today, we're going to trace the surprising, kind of unseen ancestry of the powerful computers that we all carry around in our pockets. We're going to find out how we got from simple gears all the way to the global cloud. Okay, let's dive in. So, it all starts with this really simple question, right? How did your phone get so smart? And you might think the answer is all about silicon and software, but really, it's a story that stretches back for centuries, way before electricity was even a thing. You see, long before we were streaming videos or checking email, the biggest challenge, really, was just keeping track of things. The entire history of computing, all of it, is built on this very basic human need to count, to calculate, and to organize information. So our story really kicks off in what we call the analog age. This is way before electricity, before a single circuit. This is when humans were solving some seriously complex problems with these ingenious physical tools. This was computation you could literally hold in your hands. The first methods were super simple: counting sticks, tying knots in a rope, and of course, the abacus, which is still used in some parts of the world today. But a huge step towards mechanizing math came in 1614 with something called Napier's bones. They were basically these rods with multiplication tables carved on them, a super clever tool that turned a hard multiplication problem into just adding things up. And that idea leads us right to this, the slide rule. For something like 300 years, this thing was the absolute best friend of every engineer and scientist out there. It's basically two rulers, a slide, and a rule that move past each other, and you've got this little cursor to mark your spot. It looks pretty simple, but wow, its power was revolutionary. Okay, and this is where you can see the absolute genius of the slide rule. It's all built on this cool mathematical idea called logarithms. So instead of trying to multiply 2 by 3, you just add the length that represents the log of 2 to the length for the log of 3. And guess where you end up? Right at the number 6. It's brilliant. It literally turns multiplication into addition, and division becomes subtraction. It's a physical computer. Okay, so we've got these manual tools. What's the next big leap? Well, it's the dream of a machine that could actually think for itself. This kicks off the mechanical age, where the goal wasn't just to help people calculate, but to completely automate the whole process. So, back in the 19th century, one of the biggest problems was, well, us, humans. We make mistakes. You had these tables for navigation and engineering that were calculated by people whose job title was literally computer, and these tables were just riddled with errors. So Charles Babbage came up with this radical solution: the difference engine. It was this massive, gear-driven machine designed to calculate and print these tables perfectly, every single time. Now, here's the thing. Babbage never actually finished his machine, but the idea was absolutely revolutionary. For the very first time, someone had imagined the entire computing process: input, processing, storage, and output, all as one automated system. The idea of using gears and registers to hold a value, click over to the next, and carry a number, that was the direct mechanical ancestor of our digital computers. I mean, it was basically a computer made of clockwork. Just incredible. All right, so moving from clunky mechanical gears to zippy electrical circuits, this was the game changer. This was a huge moment in computing history. And like a lot of huge technological leaps, it was kicked into high gear by the intense pressure of war, which needed more computational power than anyone had ever imagined. And the problem they were facing was just massive. Over at Bletchley Park in the UK, codebreakers were up against the German High Command's Lorenz cipher, a code that made Enigma look like child's play. The math needed to break it was so gigantic that it was just impossible for humans to do it fast enough. They needed a totally new kind of machine. The solution? A machine called Colossus, and its secret weapon was the vacuum tube. The first version, the Colossus Mark I, used 1,600 of them. Can you imagine? I mean, most people thought, there's no way this is going to work, all those fragile glass tubes. But an engineer named Tommy Flowers believed it could, and his machine helped change the course of the war. And what's so fascinating is that this revolution was happening on both sides of the Atlantic at the same time. While Colossus was busy breaking codes in the UK, the ENIAC was being built in the US to calculate artillery firing tables. So you have two different machines built for two different jobs, but they both prove the exact same absolutely critical point: electronics. That was the future of computing. Okay, so now we've got these gigantic, room-sized electronic brains that run on thousands of fragile vacuum tubes. The next huge challenge was really a question of scale. How in the world do you take that and shrink it down into something you or I could actually own and put on our desks? Well, the answer came when we replaced those big, hot vacuum tubes with the tiny little transistor, and that led to the microprocessor. Its invention in 71 just unleashed this explosion of innovation. I mean, look at this timeline. The pace is just wild. In only 6 years, we went from putting a computer on a single chip to a build-it-yourself kit for hobbyists to the Apple II, a complete system that brought computing into our homes. I mean, the shift it was night and day. This chart really drives it home. Computing went from this centralized, multi-million-dollar resource that served a whole company to a personal tool that cost a few $1,000s and just sat on your desk. It was a complete change in who could get their hands on computing power and what they could do with it. And this whole idea of getting computing power to the people, it had a really surprising hero, the simple pocket calculator. These little guys did more than just math. They helped drive down the cost of microprocessors. And maybe more importantly, they made people comfortable with the idea of having personal, portable computing power with them every day. So once everyone has a personal computer, what's the next logical step? Well, of course, you connect them all together. And this brings us right into the modern era, which is all about one challenge. How do we access huge amounts of computing power and data from anywhere, on any device we want? This idea of the cloud didn't just pop up out of nowhere. It was a step-by-step evolution. We started with powerful but isolated mainframe computers. Then we moved to clusters of cheaper machines all working together, and then to grids that connected systems all over the world. Each step got us closer to the idea of the cloud we have today, treating computing like a utility, like electricity, something you can just plug into whenever you need it. So when people talk about the cloud, what do they actually mean? Well, this table breaks it down into 3 main flavors, and it's actually pretty simple when you look at it. At the bottom, you have infrastructure as a service, or IaaS, which is like renting raw computing power. Then you have platform as a service, PaaS, which gives developers a place to build apps. And at the top, you have software as a service, SaaS, which is what most of us use every day, apps like Google Drive. And the secret ingredient, the magic that makes all of this work, is something called virtualization. The easiest way to think about it is like this. It's technology that lets one single physical server pretend that it's actually many separate, independent computers all at once. This incredibly clever trick is what gives the cloud its amazing efficiency and scale. And that brings us all the way back, full circle. From simple tally sticks and slide rules, to gear-driven engines, to room-sized electronic giants, and now to this global, virtualized cloud. All of that history, all of that genius, has come together in that one powerful tool you hold in your hand every day. When you look back, every single step on this journey, from gears to the cloud, was all about solving a problem. So that leaves us with the big question, for you and for me. As our tools get even more powerful, what's the next great problem we're going to solve?